So good morning everyone, welcome to the channel, and today we are going to revise mole concept in we will see how many minutes. And so without wasting further time, let's begin. But I just want to say one thing, that this is supposed to be a feedback video. You are supposed to tell me where I should improve, and yeah, so now let's look over the basics. First of all, this is how you have to represent an atom. This is the symbol of the element. This is the mass number. This is the atomic number. Keep in mind, this is a revision video, so I expect you to have read this at least one time earlier. So let's learn about the atomic mass unit. Atomic mass unit is nothing but it is 1/12 the mass of this atom, which is the isotope of carbon, which has 6 protons and 6 neutrons, and one atomic mass unit is nearly equal to the mass of a proton or a neutron. However, if we look at the microscopic scale, the mass of a neutron is slightly higher than that of a proton, both of which are slightly higher than one atomic mass unit. Now, what is a mole? Mole is nothing but it is the dozen of chemistry. One mole of anything is n naught number of that anything. And what is n naught? It is 6.022 into 10 raised to the power 23 entities. For example, if I say n 1 mole of steel bottles, that means I have 6.022 into 10 raised to the power 23 steel bottles. That is a lot of steel bottles, but yeah. If I say 1 mole of H2 molecule, that means I have these many H2 molecules. If I say 1 mole of H2 moles, that means these many moles of H2. Now you understand? The number itself is not tied to anything. I can't say that this number is used to refer to only moles, only molecules. No, it can be used to refer to anything. Just like you can say, I need 1 dozen of bananas, or I need 1 dozen of apples, or 1 dozen of cats or dogs. But why does this number exist in the first place? It is nothing but it is to show the mass of atom in a measurable scale, and to be more specific, it is nothing but a conversion factor between the microscopic atomic mass unit and the microscopic grams. How so? Well, one atomic mass unit is these many grams, which means the mass of a 12C6 carbon atom is going to be 12 times of this quantity. If 1 AMU is this many grams, then N naught AMU is exactly 1 gram. I believe that is easy to understand. And what follows from this, evidently, is that one atomic mass unit is nothing but the reciprocal of Avogadro's number into grams, which means that if 1 gram is N naught AMU, then 1 AMU is 1 upon N naught grams. I think that's easy to understand, and this is just a conversion between gram and kilogram. So, as an example, if we say if one molecule of water is 18 atomic mass units, then n naught molecule of water is 18 grams. I think that's easy to understand. Now, what is a gram atom? A gram atom refers to nothing but the 1 mole of anything. 1 gram atom is 1 mole, and gram atomic mass is evidently the molar mass, which is the mass of 1 mole. Okay. Now, as a question, let's see what is the mass of 314 N7 atoms. I have written the instructions on how to solve. You see the mass of one of those atoms. You find the mass of 300 of those atoms by multiplying with 300, and then you find the mass in gram by dividing with Avogadro's number. Now, for any atom, its mass in AMU is equal to AAMU. What is A? A is the mass number. In any atom, the top number is its mass in atomic mass units, and its molar mass when expressed in grams. Now, the molecular mass of a compound is simply the summation of atomic mass of all of its elements, and of course, this is multiplied by how many times that element occurs in the compound. For example, if we see C6H12O6, then we are going to add the mass of carbon 6 times and the mass of hydrogen 12 times, and so on. The relative atomic mass is nothing but it is the ratio of the mass in atomic mass unit to that of one atomic mass unit, and this is a unitless quantity evidently because mass upon mass gives dimensionless. And keep in mind the NCERT states that atomic mass unit can also be called unified mass, simply shown as small u. Now some important definitions we have to look over. If any two atoms are isotopes, then they have the same atomic number but different mass numbers. If two atoms are isobars, they are having the same mass number but different atomic numbers. If they both are isotones, that means they have the same number of neutrons. Well, how do we say number of neutrons? See, the Z is nothing but it is the number of protons because it is the atomic number. And since electron mass is negligible compared to internuclear particles, we can say that the mass number is nothing but the sum of neutrons and protons. So if we do A minus Z, we get the number of neutrons. So here we see 14 minus 6 is 8, 16 minus 8 is 8. Hence these two are isotones and have the same number of neutrons. Now what is isodiaphers? Isodiaphers is neutronic excess. What does this mean? Well, this is the number of neutrons, and now we want to see that if the number, how many more neutrons are in comparison to protons. So if we want to see the absolute difference, we will have to subtract Z one more time from the number of neutrons. So we get how many more neutrons are there in comparison to protons, and these two elements are isodiaphers. Now what is isoelectronic? Isoelectronic are entities which have the same number of electrons. For example, you can verify this. They all have 10 electrons around the central atom. And what are isoesters? These are compounds that are isoelectronic but also have the same atomicity. For example, carbon right here has, what is the atomic number of carbon? It is 6. So it has 6 electrons, while 2 moles of oxygen are going to have 8 into 2. So total 22 electrons, and here 1 mole of O is going to have 8 electrons, but 2 moles of nitrogen are going to have 14 electrons. So this plus this is again 22. So they have the same number of electrons and they also have the same atomicity. Both have 3 atoms. That makes them isoesters. Okay. Now let's look at some more definitions. These are the ways we can find the number of moles of a substance. If its mass is given, we divide it by the molar mass. If the number of entities are given, we just divide it by Avogadro's number. And this is interesting. If we know if it is a gas and it occupies some volume at 0 degrees Celsius and 1 atm, also known as standard temperatures and pressure, that volume when divided by 22.7, that gives us the number of moles. How did we get this value 22.7? Well, at STP we know the temperature and the pressure, so using the ideal gas equation we put T and P, and for 1 mole we put N is equal to 1 and R we already know. So that's how we get the value of volume, which is 22.7 liters. And these are some alternate forms of the ideal gas equation. This is pressure into volume is equal to number of moles into ideal gas constant into temperature. This is pressure into molar mass of the gas equal to density of the gas into ideal gas constant into temperature, and this is pressure into volume is equal to absolute number of molecules of the gas. This is not number of moles anymore, this is number of molecules. And to make up for this conversion, what we do is we substitute R for a constant called Boltzmann constant, which is nothing but the ideal gas constant divided by the Avogadro's number. If you put K is equal to this, you will see that you can easily change back to whatever this was. Now let's see empirical versus chemical formula. Well, empirical formula is the simplest ratio of the number of atoms in any compound. For example, this is the chemical formula of glucose, but if I were to write its empirical formula, it will be CH2O. Why? Just divide everything by 6. It is the simplest whole number ratio of the atoms in a compound, and chemical formula is the actual composition. Similarly, how we can see if this is the chemical formula, its empirical formula becomes this. This is a question on how to find empirical formula. Do check it out and tell me if you have any doubts. This is again a question on how to find the mass of these many sodium atoms. And this is a question with, you see what the question it is, volume of dihydrogen gas at standard temperature and pressure if it has as many hydrogen atoms as 98 grams of this acid. We just see that if it has equal number of H atoms and one one mole of dihydrogen has 2 atoms, so we multiply by 2 here, and N naught is to convert moles into molecules. We have to find the volume. So here we see if we divide volume by 22.7 at STP, we get the number of moles. And if multiplying the number of moles by how many hydrogen are in 1 mole, and then we multiply by Avogadro's number. Well, this wasn't really necessary here since it would cancel out, but still it's to show you what should go through your mind. And this quantity is equal to 3 times the Avogadro number into the number of moles of H3PO4. Its molar mass is 98 and we are giving 98 grams. So this is just 1 mole, and hence the X comes out to be 34.05 liters. Now these are some more definitions. These are percentages basically. If you are ever asked to find percentage composition of a compound, you just have to see favorable mass upon total mass into 100. That's it. For example, if I want to see what is the mass percentage of carbon and oxygen combined in cane sugar or C12H22O11, I just see the favorable mass. What is the favorable mass? 12 atoms of carbon multiplied by the atomic mass of carbon plus 11 atoms of oxygen into 16 atomic mass of oxygen divided by total mass that I have. This also includes the hydrogen, and if we multiply by 100, we will get our percentage composition. Similarly, we define percentage purity, the mass of the favorable compound into 100 upon the total mass of the sample. For example, if I say I have 90% pure water and I have 100 grams of it, that means that I will end up with 90 grams of pure water. I think this is easy to understand, and if you want to find the number of moles, it is 90 upon 18 molar mass of water, which gives 5 moles. Excuse my throat. And if we see percentage yield of a reaction, we will see how much the reaction actually gives in reality, which will be given in the question. And by using the reaction, like the balanced chemical reaction, we can also find the expected mass of the product. So by dividing the observed mass by the expected mass and multiplying by 100 to show it in percentage, we can get the percentage yield. I think this example is easy to understand. You have been given a reaction, and then it's giving you a real life scenario. When we tried to do this reaction, this much product came out, but actually this much product should have come out if the reaction went to completion. So to find the percentage yield, you divide the observed mass of product by expected mass of product into 100. Now one more definition. What is the average atomic mass of any element? Well, you must have heard that chlorine has an atomic mass of 35.5. How do I get half a proton? Well, it comes from the fact that how we define atomic mass of an element when it has multiple isotopes with varying mass numbers. So what we do is we look at their relative abundance and we take the weighted average of all those isotopes. What is weighted average? Basically summation of the decimal out of 1. For example, if Earth has 75% chlorine, then the decimal is 0.75, and 25% of 37 mass number chlorine. So what is the average mass? We just multiply the abundance into the atomic mass and we just sum them, that's all. 0.75 into the mass number of this guy plus 0.25 into mass number of this guy, that's it, and we get 35.5. Now another definition, vapor density. It is nothing but the molar mass of gas on upon the molar mass of dihydrogen. So it is essentially, it is nothing but the molar mass of the gas divided by 2. Don't get scared by this term, it is basically just half of the molar mass. And to be honest, this is defined as density of that gas upon density of H2, but to write density there would be upon RT term here, which just cancels off, so I directly wrote it like this. Now what is formula mass? Well, it is the same as molecular mass, nothing's different, but we prefer to call it formula mass for ionic compounds. Now let's learn about chemical reactions. What are the laws of chemical reactions? These are direct screenshots from the NCERT. Make sure you look at all of these statements and it will be better if you memorize every nuance about them. Law of conservation of mass is obvious, we all know. Law of definite proportions say that no matter where you get a compound from, it will always have the same composition. For example, if I pick up water from a Bisleri water and I pick up water from the Nali, it has the same composition. It is always H2O. The Nali one might have some insects, but the water is what we are concerned about. And if we look at law of multiple proportion, this is a very stupid law and serves no purpose, but it is in the NCERT. It says that if two elements combine to form more than one compound, for example say CH4 and C2H6, then the masses of one element that combine with a fixed mass of the other element are in ratio of small whole numbers. So CH4 and C2H6, actually this is not a good example, just let it be. Let's look at the example in the notes. Hydrogen and oxygen together form two compounds, and here the ratio of oxygen in both of those compounds is 1:2. Yay, the law is followed. Very idiotic and obvious law. I hate this law, but anyway. Let's look at Gay-Lussac's law. When gases combine or they are formed in reaction, they do so in fixed ratio by volume. Just remember this statement. And this thing, at least 12 previous year questions have come in JEE Mains and NEET from this directly. Only these statements. It does not matter if they are correct or not. This is what Dalton, a scientist, John Dalton, thought at the time. So you just have to remember these statements, what he said. For example, this may not even be true. All atoms of a given element have identical properties, but we just learned about isotopes. So this is false. A lot of it is false. Indivisible atoms, we can divide them into electrons, protons, neutrons. Again false, but just remember what Dalton thought, and this was the most widely accepted theory at that time. Knowing the history of a subject is just as important as knowing the subject, and which is why they asked from this topic. And keep in mind the limitations of Dalton's atomic theory. It could not explain why atoms bind in the first place, and it could not explain the Gay-Lussac's law. Now let's learn about stoichiometry. Well, stoichiometry is nothing but the art of mustering and gathering information when we are given the balanced chemical reaction. For example, if we are given the balanced chemical reaction, this one, then what information can we find out? These are all the information that we can deduce from this, and just go through it once. This should be obvious, and this is some extra stuff I added. In this reaction, if I take n number of something, where something is mole, molecule or liter, the volume occupied by the gas, it is that n number will react with 2n number of O2, which means the stoichiometry of a reaction never changes. This is similar to the law of definite proportions. the composition of a substance never changes, and the overall pathway or the balanced chemical reaction of a reaction is never going to change. The n number of methane is going to react with 2n number of O2 and give n number of CO2 and give 2n number of H2. Okay. Now let's learn about the concept of limiting reagent. It is nothing but the reactant that gets finished earlier. That's it. That's all you need to know. How do we find the limiting reagent? We use a series stoichiometric amount. How do we find stoichiometric amount? Well, again, you will be given two scenarios. One in the idealized version where you will be given the balanced chemical reaction basically, and you will also be given a real life scenario in which this reaction was carried out. So what you have to do is you have to see the given moles of a reactant in the reaction, and you have to divide it by the number of moles in the balanced reaction that you have been given as a point of theory. And the limiting reagent is the reactant that has the least stoichiometric amount. For example, if I see a reaction between lead chloride and ammonium phosphate, which gives products, and then this is JEE's 2024 POAC, by the way. If we have 72 moles of lead chloride and we react it with 50 moles of ammonium phosphate, what is the limiting reagent? So just as we have been told, we will see the stoichiometric amount, and the stoichiometric amount of PbCl2 is given moles upon number of moles in balanced reaction. Stoichiometric amount of ammonium phosphate is given moles upon number of moles in balanced reaction. So if we compare 72 by 3, which comes out to be 24, and 50 upon 2, which comes out to be 25, we can see that lead chloride has the least stoichiometric amount among the two, and hence it is the limiting reagent. Now let's look at the principle of atomic conservation, or POAC. Well, we use it when balanced reaction has not been given to us. And how do we use it? Well, mass of any atom or number of atoms is conserved. Well, number of atoms is not conserved if we are talking about nuclear reactions, but here we are only dealing with chemical reactions. So mass of an atom or number of an atom is conserved. Now how do we use POAC to our advantage? Here we see that if we use magic on nitrogen, it suddenly forms this guy. And we say it as a chromium complex with X number of ammonia ligands and 2 bromine ligands. How do we find X? Well, we have been given that this reactant is 6 grams and this is 30 grams. So we will apply principle of atomic conservation on nitrogen. 2 into moles of N2. Why did we multiply 2 here? Because 1 mole of N2 has 2 atoms of nitrogen. We are basically equating the number of nitrogen on either side. And on this side, we see that X ligands are there. So X into the moles of product. We will see how many moles of the product are there, and if we multiply it by X, we will get how many atoms of nitrogen are on the other side. So substituting the values, we get this equation, and X upon solving gives you X is equal to 4. This is a JEE mains PYQ again. Now let's look at Eudiometry. Eudiometry is nothing but it is gas experiments which are based on stoichiometry and principle of atomic conservation. These are some important points to keep in mind. This is the general equation of combustion of any hydrocarbon. Combustion is nothing but burning in the presence of oxygen. Keep in mind, this is a very useful reaction. It will almost always help you in one way or the other. And lot of questions have come directly from this point in JEE Mains 2026. And another important point that dinitrogen cannot combust, it cannot burn. For example, if I let all x, y, z is equal to 0 and put 2 here, no, it is not going to combust. Okay, so we need to make sure that all of the gases that are taking part in our question are measured at the same pressure and temperature. And these are some absorbents basically. You have to keep in mind that, and this is a base, and CO2 is an acidic oxide. So KOH absorbs CO2, anhydrous calcium chloride absorbs water, turpentine absorbs ozone, Ammoniacal Cu2Cl2 absorbs carbon monoxide. Basic pyrogalol absorbs oxygen, and CuSO4 absorbs NH3. How will this help you in the question? Maybe they will give you a question that this gas is put in a tube. A mixture of gases is put in a tube. For example, say H2O, CO2, and CH4 is put in a tube, and first I react it with KOH, and it will tell you the volume change, and using that volume change you have to find out how much CO2 disappeared. Similarly, maybe in the next step they will give you anhydrous CaCl2, and it takes away the water and gives the volume change again. Hence you will have to find out how much volume of water was there, and this is how it works in the end. So this is another question and the last question of today. What is the volume of oxygen needed for combustion of 40 milliliters of ethane? Well, in this general combustion reaction, we know ethane is C2H6. So we put Z and W is equal to 0, and X is equal to 2, and Y is equal to 6. So this compound becomes ethane. And then we know the values of X and Y. So we substitute here and here. So all in all, we get to know that we need 3.5 moles of O2 for combustion of 1 mole of ethane. This value comes out to be 3.5. And hence, we can say that 3.5 upon 1, the ratio is going to be the same, is equal to x upon 40. This is not the same x. Actually, let me change the variable. Let me call it V. So, the volume upon 40 is equal to the molar ratio 3.5 upon 1, and it gives us volume is equal to 140 milliliters. And lastly, this is some extra information that I scooped out from the NCERT, so you don't need to read the NCERT after this. Cisplatin and Taxol help in cancer therapy. A drug called azithromycin is used for helping artificial intelligence and data science. Oh no, AIDS patients. And a mixture contains, it is basically a definition of a mixture. A mixture is nothing but it is particles of two or more pure substances which is mixed in any ratio, which means it's not like a compound where there's a fixed ratio and a law of definite proportions, but mixture can have any ratio. And a homogeneous mixture mixes completely with each other, composition is uniform. And a heterogeneous mixture, the composition is not uniform. Okay. The melting point of water in Fahrenheit is 32. Boiling point is 212. These are the isotopes of carbon. This is the full form of CGPM, the company, not the company, but the organization that decides the SI units. These are the greenhouse gases which cause global warming. We use 1 dozen for 12 items, score for 20 items, and gross for 144 items. And this is how the Avogadro number was derived. Like I told you, 1 upon 12 times the mass of the carbon 12 atom. And that's it. We have revised complete mole concept along with NCERT extra points in less than 30 minutes. So let me add the duration here in 28 minutes. So thank you for attending this lecture, and that's it. Please give me feedback on how it was, and I want to put out more content in the coming months. Thank you. Subscribe.